Hi, this is Mr. Manley. In this video, we're going to look at inverse trigonometry, and I might add here with exact values, because that's going to make this a little bit more interesting than just using a calculator and doing a decimal approximation. A little bit more challenging too. So first of all, I presume you have some familiarity with inverse trigonometry. For instance, if you were solving triangles or working with the right triangles and you ended up with sine x is equal to 4 over 5, perhaps you know that in order to solve for sine x, or in order to solve for x, the angle, a way of thinking about that is to take the inverse sine of both sides, and then from there, we would have a calculator key in, because sine undoes itself, right? The inverse sine of sine x is x, and then that would equal whatever this value is, and we could key that into a calculator and figure out what angle that is. So if you've done that, then you've been doing inverse trigonometry. But we're going to get a little bit more specific here with these exact values that I'm talking about. And in order to do that, we're going to go into some detail here that is a little bit challenging. Here is an expression. I would read this as the inverse tangent of rad 3 over 3. This is going to be challenging for a few reasons. For one, we're not going to use a calculator. We're going to find this value exactly using the unit circle. So that's the first difficulty. Second difficulty. Let's define what this means. Let's make a statement about what this means. This is the angle with tangent value of rad 3 over 3. So if I could answer that question, I'm almost there, but there's a couple more complications. But if I could answer that question, like I said, I'm almost there. What angle is it that has this tangent value? So let's take a look at that before I get into some further detail. If I look over at the so first of all, before I go over and look at the unit circle, remember, as I go over the unit circle, that on a unit circle, the tangent value of an angle is equal to y over x. So let's hold on to that. Now, moving over the unit circle, I'm looking at some of these values here. Like here at 30 degrees, that has coordinates of rad 3 over 2 and 1/2. And here at 60 degrees, that has coordinates 1/2 and rad 3 over 2. So this is really basic arithmetic at this point. Which of these xy coordinates, so I've got the x coordinate and the y coordinate for both of these. If I do y over x, which one comes out to rad 3 over 3? All right. So hopefully, if you took a moment to think about that, you would be able to come up with this one. It's the 30 degrees. So if you look at the y over the x, that's going to be 1 over rad 3, which is rad 3 over 3. So there's a little bit of that's really just a basic arithmetic challenge. Okay, so we really have answered the question here. There is going to be a further complication later on, but we have answered the question that the inverse tangent of rad 3 over 3 is equal to 30 degrees, or if you were asked to answer in radians, you would say pi over 6. Okay, now here's where the difficult part is. I'm just going to change one thing here. I'm going to change the sign to a negative. So I've got negative rad 3 over 3. Now I have the same interpretation. It's the angle that has tangent value of negative rad 3 over 3. All right, and then we're operating off of that understanding that tangent values on a unit circle are y over x. So you might look at this and maybe you could find your way to it and see, all right, over here at 330 degrees, I've got these coordinates, rad 3 over 2 and negative 1/2. All right, so I've got a negative there. And when I do the negative y, or the negative 1/2 over rad 3 over 2, I'm going to get negative 1 over rad 3, which is negative rad 3 over 3 after I rationalize the denominator. So I seem to have it. And I might want to say 330 degrees. But here's the problem, all right? And this is a little bit frustrating, but we can't say that. Because the thing is, there are infinite possibilities for all of these, right? Let's go ahead and take a look. If I were on a circle, and if I rotated around that way, that's 330 degrees. But the thing is, I could rotate around and end up there again. There's another angle that has that tangent value, and another angle, and another angle. And the thing that we're going to agree on in order to eliminate all of the possibilities and narrow it down to one that we're going to agree on, we're actually going to rotate this way. So look at my angle. I'm going to rotate this way. So I'm actually going to call my answer not 330 degrees. I'm actually going to call it negative 30 degrees. So in this definition for tangent, I'm actually want to amend it and say it's the angle, and then I'm going to put a restriction on it. The angle that's between negative 90 degrees and 90 degrees. So you see that interval notation? Hopefully you remember interval notation. So that is an interval notation that says between negative 90 degrees and 90 degrees. So it's the angle between negative 90 degrees and 90 degrees that has tangent value of whatever it is, rad 3 over 3, negative rad 3 over 3. Okay? So that's how tangent works. Sine actually works the same way. So let's go ahead and take a look at a sine inverse function. I just slap a sine in there. Let me put a value that'll work better here. We'll go 1/2. So if you read this, you're going to say it's the angle, and again we're going to go between negative 90 degrees and 90 degrees, and I'm talking in degrees here because I think you're probably more comfortable with that, but we have to be able to talk in radians too. So we would have to be able to convert that and say negative pi over 2 to pi over 2 radians. But we'll just stick with degrees now, since this topic is challenging enough without throwing radians in there for you. So it's the angle between negative 90 and 90 degrees that has sine value 1/2. Now sine on a unit circle is y over r. And on a unit circle, since r is 1, essentially I'm looking for the coordinate, a y coordinate of 1/2. And if you look at my picture over here, I just happen to have, no, yes I do. I just happen to have it right there. There's a y coordinate of 1/2. And what angle is that happening at? 30 degrees. So I would be able to answer that. Negative, if I do a negative, let's see the angle. So let's just throw in a negative right here. Negative 1/2. Negative 1/2. And then again, there it is right there. But I'm not going to call it 330 degrees. I am going to call it negative 30 degrees. Of course, there's that word coterminal, right? Negative 30 degrees is coterminal with 330 degrees, which means they have the same trig values. And the negative 30 degrees is the one that we want to use. So far, so good. Maybe you got tangent under your belt, and you see, oh, sine, it's same thing, very similar. We take a little shift, though, with cosine. So with cosine, let's take a look at that. And I'll just keep the negative 1/2 there. The inverse cosine of negative 1/2. And in this case, it's going to be the angle. Now, I can't do negative 90 degrees to 90 degrees for cosine. Maybe you could see why. If you look over here on this side of the graph, if I stay on that side of the graph, I'll never get a negative x value. And anybody who knows anything about trigonometry and the unit circle knows that cosine theta is equal to the x value. So I need to have some negative x values. The way that I'm going to get that is say that we're going to be on the interval from 0 to 180 degrees. So the inverse cosine of negative 1/2 is the angle that is between 0 and 180 degrees that has cosine value negative 1/2. And since I know that cosine on a unit circle is the x-coordinate, I'm just looking for an x-coordinate of negative 1/2. And if you have your unit circle, you can look at it. I happen to know that that's going to happen right up there. Right up there, I'm going to have the coordinates negative 1/2, rad 3 over 2, and that is happening at 120 degrees. And that's my answer. So that's inverse trigonometric functions with exact values. A little bit difficult. There's some specific things that we need to memorize about the intervals that we're operating on. And it can get a little tricky for students to think about, well, what is this? What is this talking about? But I think if you write these sentences down the way I'm writing them down, you'll be interpreting your inverse cosine expressions correctly.